everyone, and welcome to Frogs, Fleas, and Painted Cubes 2.3. This begins on page 32 of your textbook. Our learning target today is that I will be able to correctly factor trinomials. ACEs questions for 2.3 are numbers 41 through 50 and number 61. Well, what exactly is a trinomial? It's an equation that has three terms in it. And so we have our x squared term, our bx term, and our c term. Well, when factoring a trinomial with a coefficient of x squared of 1, pretend there's a 1 in front of our x squared here, we always want to try to find factors of c. So factors of c, things that are multiplied together for c, that when you add those two things that we factored together, when you add them together, that they come up with the value of b. To give you an example, over here we have x squared plus 7x plus 12. Well, if we're going to find factors of c, as in things that you multiply together to come up with 12, what are some of our options? Well, we could do 1 and 12. Okay, so 1 times 12, and then to add them together, we have 1 plus 12, and that equals 13, okay, which is not what we're looking for. We need 7. So let's try again. So if we go 2 times 6 to get to 12, well, 2 plus, oops, it's not a good plus sign, 2 plus 6 equals 8, okay? That is not what we're looking for either. So if we do 3 times 4, we get 3 times 4 is 12, and 3 plus 4, okay, is also what we need of 7. Okay, so 3 plus 4 is 7. So these are going to be our two factors, and then all we have to do is break up into our two different binomials, our x plus 3 and our x plus 4. And when we multiply these two binomials out in expanded form, we will wind up with x squared plus 7x plus 12. If you don't believe me, x times x, x squared, okay, that's our first. Our outer is 4x, okay, our inner here is 3x, oops, need my plus sign in here, and our last is 3 times 4, or 12, okay? And when we combine like terms, we get x squared. You add the 4x plus the 3x, then you get 7x plus 12. Hopefully that kind of gives you an idea of how to go about trying to find factors that when added together will give you your middle term. If we look here at 2.3, we're factoring quadratic expressions. There's a couple of different ways to do that. So Ms. Parath's class summarizes two ways to rewrite a factored expression, such as x plus 2 times the binomial x plus 6 in expanded form. Well, we can use the rectangle model where it's given us all of the links here, and we can then go ahead and fill things in, which is what's going on right down here. They've taken this information from these sets of rectangles, and we have x plus 2 here, which is x plus 2, times our x plus 6, because that's the length of this side, x plus 6. And they are looking at factoring out an x and a 6. So if we factor out an x from both of them, we wind up with x plus 2 times x plus 2 times 6. If we go ahead and label the areas and we take this x times this x, we get x squared here, and this x times this 2, we get 2x. All right. We take this 6 times this x, we get 6x here, and we take this 6 times this 2, and we get 12 up here. So we have x squared, if you take all of these, we have x squared here, plus 2x here plus 6x plus 12 to get the area of our whole rectangle. So that's one way we can go about it, and combine like terms, we get x squared plus 8x plus 12. We can also take what we had up here, our x plus 2 times our x plus 6, and we can use our FOIL method to come up with x squared plus 2x plus 6x plus 12. Again, you combine them, x squared plus 8x plus 12. So one's a rectangle method, and one is our FOIL method. So be familiar with both ways to do that. Well, it tells us now that in problem 2.2 question E, you expanded expressions like x plus 3 squared. The expression x plus 3 squared is an example of a binomial squared. We've kind of gone over what a binomial is before, but we'll do that again here. A binomial is an algebraic expression that is the sum or difference of two terms. For example, x plus 3 is one binomial, x minus 4 is another binomial, and 2x plus 4 is another binomial. The two factors of a quadratic expression in factored form are examples of binomials. If we look down here, x plus 2 times x plus 6, well, each of these is a binomial. X plus 2 is one binomial, and x plus 6 is another binomial. With that, Lydia noticed the following pattern. She said, when you square a binomial, the expanded form has three terms. So we start out with x plus 3 squared, which is what we have up here. Keep in mind that x plus 3 squared does not equal x squared plus 3 squared. That is part of it that we're doing, but that is not all of it. When we write this in expanded form, our x plus 3 squared means we have two terms of x plus 3. So you would write in expanded form like this. Okay? So now Lydia says the first term in the square is the binomial, or we are squaring the first term. So she would be correct. We're over here. If we use our FOIL method, we would be squaring the first term to get x squared. Then the second term is twice the product of the two terms in the binomial. So she's saying that the second term is going to be 2 times this. So she's saying that the second term should be 6x. Well, if we go inside, we have plus 3x. And if we go outside, we also have plus 3x. Well, 3x plus 3x would be 6x, as she's showing us here. And then the third term is the square of the second term in the binomial, or 3 squared. Well, last for us would be 3 times 3, or 9. So hopefully you can see how that works, that if you are given a binomial that is squared, that you are going to wind up going with this pattern that Lydia suggested, that the first term is squared, or 2 times the second term, or 2 times 3 is 6, okay, for the middle term, and then squaring that second term, this last term in here, to get our final 9. If we turn a page and begin on page 34 for our homework, we'll go over this part in class, but I want to skip to our homework right now. So copy the diagram below, replace questions. I want you to, as I say up here, go over A and B with your table mate just together, and then part C, E, and F to do in teams. Here they give you this side length, and then they give you this area as well as this area. They want you to be able to deduce from that what these other parts should be. So write two expressions for the area outlined in red. And part B, consider this expression, choose value for B that gives an expression that we can factor, and then compare your work with your teammates on that. Part C, this is some good practice. They give you the expanded form and want to determine what the factored form would be. So they give you part of the answer, and then want you to find R and S. On the first one, they give you 3 of the 4. On the second and third, they give you 2 of the 4. And so use some of the practice I did on that very first page of introduction of this to determine how to come up with the correct factored forms. And finally, E and F here is just more practice doing the same thing. So lots and lots of practice, and look forward to seeing your questions and solutions in class. Thank you.